Bismillahirrahmanirrahim. This is third video of source-free Series RLC circuit, and we'll just recall the problem solving strategy that we had formulated. We need to find I0, V0. We need to find di dt 0 through KVL. Then we find alpha and omega and S1 and S2 or WD if required. We write the general equation, IT equation, and then from IT equation we find A1 and A2. So let's take the first question. This is the same question we did in the previous video with only one change. The value of resistance is now changed to 6 ohm. Let's see what will be its effect. So we'll follow these steps, same steps. For t less than 0, we need to find I0 and V0. So the circuit for t less than 0 will look like this. It is like this. The inductor has been short circuited. So 100 volt divided by 10 ohm will give the I0 current. So I0 is 100 divided by 10 ampere. And V0 is the voltage across capacitor. Since this is no more not in the circuit, therefore V0 is 0. So we write V0 is equal to 0. So that's the first step. Now the second step that we have to, for t greater than 0, we have to write the Kvl equation, and then from there we have to solve di dt. So let's move towards the right hand side. So we move the switch at t is equal to 0, and this is the transient period, so inductor is not short circuited as yet, neither the capacitor is open circuit. So we write the KVL equation. Now based on this current, we know that wherever the current touches first, that terminal becomes positive, so positive here, negative here. Current coming, touching here first, so positive, negative. Touching here first, so positive, negative. So these are the voltage polarities. And now we can write the KVL equation. We start from here and go clockwise. So minus VL or minus L di dt, minus VC, so minus VCT, and minus RIT is equal to 0. Taking common minus, we get this equation. Putting t is equal to 0, we get this equation here, and now we plug in the values of I0 and V0. So I0 was 10, V0 is 0, so solving di0 dt is minus 60 amperes per second. Okay, now the third one is to calculate alpha and omega. So plugging in the values, we get alpha 3 and omega 3. So actually by changing this, I wanted to show you the case when both alpha and omega are same. And if you recall that when both alpha and omega are same, this is the critical damping condition. Okay, so now based on alpha and omega, we choose the current equation. And then if need be, we calculate S1, S2, etc. So critically damped alpha when alpha is equal to omega, and these were the three current equations. So for critically damped condition, this is the current equation. So we'll take that. So this is our current equation. So to get general equation, we only need to write alpha here, the value of alpha. So this was the equation, and writing the value of alpha, this is our general equation for current. And now we'll find A2 and A1 by putting t is equal to 0 and then also differentiating. So let's first put t is equal to 0. Putting t is equal to 0, this is I0. I0 is equal to A2. I0 we have already found to be 10 ampere, so we put that 10 ampere here. So A2 is 10. And then now the second step is that we need another equation, so we differentiate this. So this is the equation, differentiating And again, this is a product term, so I hope you recall the first term, differentiation of the second term, differentiation of the first term, and put t is equal to 0 here, putting t is equal to 0, so the equation becomes minus 3a2 plus a1. We had also calculated the value of di dt as 0, so we'll plug in that value. This is minus 60, so we'll plug in that here. So plugging in, we get the third equation number 3, which is this. Now we'll solve this equation and this, or we plug in the value of a2 in this to get a1. So these are the two equations. Now put in the value of a2 in this, and we can get a1 to be minus 30. So a1 minus 30, a2 10, and so our final equation will be plugging in the values in the main equation. So this is the final answer. Another equation. Now here this is the circuit. The initial capacitor voltage Vc is minus 4 volt. So Vc naught or V naught is minus 4 volt at t 0 minus. There is no current initially flowing through the inductor, so no current here. That means I0 is 0, and we have to obtain an expression for IT valid for t greater than 0. So the first step, same. We know both of these. I0 is 0, it is said here. Current, no current, so I0 0, and Vc is minus 4. So 0 volt, and Vc 0 or V capital 0 is minus 4 volt. Okay, now we come to the second step. For t greater than 0, we have to write Kvl equation, and then putting t is equal to 0, we need to find di dt. So let's see the circuit. This is the circuit, and since this is the current direction, we can mark the voltage polarity here. This is already given as minus, so we'll write it as minus, and this is plus here. So if you start writing from here, so it is plus Ri minus Vc plus LDI dt. So this is the Kvl equation. Plugging in the values of I0 was 0 or Vc minus 4. So we plug in the value here. So I0 is 0, so this will become 0 multiplied by the resistance. This is minus, and Vc was minus 4, so minus, and LDI dt. From here, LDI dt is minus 4 over L, putting in the value of L and solving di dt at t is equal to 0 is minus 4 into 10 raised to the power 3 amperes per second. So in step 3, we need to calculate alpha and omega. So plugging in the values in the formula for alpha, values of R and L, we get 5 into 10 raised to the power 5 for alpha, and similarly omega comes to be 707.11 radians. So now you can see that alpha is much greater than omega, and if you recall, when alpha is greater than omega, then we have an overdamped case. Okay, now the fourth step is that based on alpha and omega, we choose the current equation, and if need be, we calculate S1, S2 or W2, etc. So we know that alpha is greater than omega, so it was an overdamped case. So we select the current equation from the three options. This is for the overdamped case. So this is our current equation. Now here we need to find out S1 and S2 as well. So we know the formula for S1 and S2. This is the formula. We plug in the values of alpha and omega, and solving, you get this answer. And so our general equation will now be like this. We plug in the value of S1 and plug in the value of S2. And the next step is to find the value of capital A1 and A2. So in the general equation, we put t is equal to 0 to get the first equation. So we put t is equal to 0, then we get this equation. And it was equal to 0, we had calculated earlier, or it was given already. So we put this equal to 0. And then the other equation is found by differentiating this. So differentiating this, we get as shown here in equation 3, and then put t is equal to 0. Put t is equal to 0, our equation comes up to this point. We had already calculated the value of di dt, so we'll plug in this value here. So plugging in the value, we get the equation number 4, and this was the earlier equation. So by solving these two equations, we find alpha to be minus 0.004 and A2 to be plus 0.004. So we now plug in these two values into the general equation. So this is our final equation. So this is the answer. So I hope this gives you an understanding as to how to solve cases related to overdamped or critically damped as well. Thank you.